Okay, so hello everyone. Welcome to the recording here for week 7 of ARC 406, Architectural Detailing 2. Today, I was planning to maybe give something of a larger lecture, but I think because this is um, recorded this week, I'll probably focus just specifically on metal panel wall systems and get to the point of how you complete assignment 2, which is due next week. So I'll look into some additional details of the steel and foundation needed to finish off assignment number 2, which is an industrial building that is primarily steel framing. And I'll talk a little bit about metal panel wall systems and their interface with the steel and their interface up with the parapet. So I have revised the assignment number 2. I'll bring that up on the screen now. I was originally asking for a little bit more here, but I think I'd just like you to make one complete wall section detail at a column location for building described as follows: an industrial building with prefabricated wall panels, a flat roof with a single ply roofing material, 30-inch tall parapet, and then a steel structure with wide flange columns at 25 feet on center, steel joists supporting roof metal deck, and a wide flange beams supporting the building perimeter. Single story building with 25 feet from floor to underside of steel joists, and the first floor being slab on grade. So uh, what I was sort of implying here and what I've posted in the week 7 is a catalog for insulated metal wall panels, which essentially are the siding that you'll see on quite a few industrial buildings in the area. Now, these can work a couple different ways. You can buy almost like a deck that just serves as almost like a roof deck for the wall, if you will, itself. But what is also common and what is shown in this PDF I posted is an insulated wall panel where essentially your decking that has a structural capacity, your insulation, your waterproofing are all come in the same piece, if you will, of these sheets of insulated metal wall panel that all comes as a single package and gets erected on site. So this is a very easy way to put up a building very quickly if you're using this insulated metal panel. Okay. So in terms of what we would use on our building, it's going to depend on a couple different things. If you look at this catalog I posted, the thicknesses correspond to um, different R values, different values of essential thermal thermal insulation. So I doubt you'd see anything less than a 2.5 inch, probably more likely a 3 inch in this area that's shown on page 5 here. And if you're looking for the structural loading, I think I didn't mention it in the recording, the week 6 recording, but I'll mention it here. I think I mentioned it in class. Typically we have what are called girts that support the wall in industrial buildings at routine elevations, and I think somewhere between a span of 8 to 10 feet would be typical. So what it's saying here is that for either a simple span, if you just have a simple span, or if you have continuous wall panel, which we would have in our case, between 8 and 10 feet, a 2 inch thick of this Nucor wall panel can take a wind pressure of 36 psf if the span is at 8 feet. So, it's been a little while since I've run wind load calcs in the area, but I think your wind load is probably in the neighborhood of 25 to 35 psf. So if we're using either a 2.5 or a 3 inch wall panel, and the spacing of our girts is around 8 feet, we can take 48, almost 50 psf, and that's probably going to be enough. So I recommend you just take a quick look at this, and I posted this, and this is very commonly used material. So it just comes out on a flatbed, uh, that and that can be erected usually I think by a crane on site, and I think it works pretty effectively, and it's pretty commonly used in industrial buildings. So let's say we bring up, bear with me here. So let's say first I want to show basically a long or a tall wall elevation similar to what I'm asking you to put together, although this one will be a little bit different because it's a little bit older, but I think it's a good example of the detail I was trying to look for. So if I go to my drawboard PDF, bear with me. So this is similar to what your details should look like, although obviously a little better called out. But this is from some decades ago, and this is what we would call a long span uh, prefabricated metal wall panel. I don't really see these so much anymore, but how these used to work is they used to have an actual trussing inside of them so that they could span, not between girts at say 8 feet on center, but between, the I guess the floor and the actual roof, 25, 30 feet or more. I think these are getting a little less common. It's not what we're going to use for our assignment, but it's just important to see here that it sort of lands on its own little foundation ledge at the bottom, and I'll show what that looks like in a second. Um, so what it would look like for us is it really just is sort of a panel. If let's say we use a 2.5-inch panel, and then I normally draw it as almost a rigid insulation inside with a little bit of thickness on the front to represent the thickness of the panel and the thickness of the panel, and it's 2.5 inches total. Let's say we use a 2.5-inch wall panel. Okay, so it's a little less involved than this, which has a little bit of sheathing and then batt insulation inside this trussed interior. So we wouldn't really have that, but they do have this edge angle at the bottom that is then anchored in to the foundation, usually around every 12 to 20 inches, and then they have metal flashing here. They have metal flashing, so obviously any water that gets into the assembly um, will drip off, and then usually I think the drip edge actually goes out like that. So that's sort of what the base would look like. And if we go up to the top elevation here, this might not be super instructive, but once we get up to the top here, we're going to have our metal wall panel with thickness, and then the batt insulation inside. And then it goes all the way up, and usually, just like you're seeing here, there's some sort of prefabricated metal cap with a drip edge like so, that'll go over essentially the intersection of the roofing material and the intersection of the prefabricated metal panel that's on the exterior of the building. So what's sort of missing from this, and we don't have any of what's going on here because this building that I think that might be a crane system or something, so we don't really have that, but we do have, obviously we do have our column here, and we also have essentially a channel which is a girt that is acting in between the outboard edge of the column on this edge and then the inboard edge of that prefabricated metal wall panel. So I can't really draw it in there, but if this is our column, we're going to have girts that are outboard of the column that the prefabricated metal wall panel anchor into, and I apologize, there's no ruler here for me to get a straight edge. So this girt, the question would be how deep is this girt? Sorry, I was trying to highlight that. How deep is this girt? It's probably going to be a C8, I would have to guess. And depending on the loading and the span, because it's a 25-foot span, I might think that they might go to, they might use an actual C8 by 11.5, which is a common channel section. If you have shorter column spacings and lighter loads, you might go to like a cold formed steel, but you could just call this out as girt, refer to structural. C8 girt, refer to structural. Okay. So that's what we would have, and then you sort of got to, I guess, proportion where the girts are. Let's say we want to stick to about an 8-foot spacing, then you'd have to proportion them along the height of the wall elevation, And generally, I think 8 foot is a pretty good rule of thumb for how far apart these girts are going to be spaced. Now, there is a little anchor you can draw in here where the actual metal wall panel attaches to the girt itself. They might provide a hole in the girt, and then some sort of screw, some simple screw that's going to go into the metal wall panel. But it's not really much more complicated than that. I don't think I'd show it at a column elevation, but there are essentially tie rods that hold the various levels of girts up, because they can't really support their own weight. And well, let me amend that. I think it might make sense on this detail to actually show the tie rods themselves. Say tie rods, I would think at probably at 36 on center minimum, because I think up at the top, up at the parapet level, it might make sense to show that. So they're actually probably 3/4 inch rods with a little nut here and a little nut here, and they're being supported up at the top. They're essentially hanging from structure that is at the top of the column, so that that the girts don't sag under their own self weight. So you don't really see a girt in this detail because this metal wall panel is capable of taking that load all the way up from the base, from the actual floor here, all the way up to the roof. So we didn't talk too much about the foundations. I think I talked a little bit about it in class, but I wanted to more show a detail here. So for the little strip of wall that the wall panel actually lands on itself, and I would say ignore this, this is going to be whatever it needs to be. Your wall panel is going to come down to the bottom here, and it's going to fit up against an angle, an L3x3 with half-inch anchor, sleeve anchors at 24 inches on center. I'd say that would be pretty common. And then it's going to have a metal flashing detail like I was showing before, so that we can move water away from the elevation. And they've got this little 3/4 inch notch here, which also helps with getting water off the face of the elevation. So you don't have to give me the whole slab detail again. You can just sort of draw. You can reuse the slab detail from before. You don't need to call it out, obviously. I'm not really asking for a slab detail here. But then they have sort of what I was describing before for what is a non-structural wall footing. You can get away without any sort of footing at the base here. You can just have a rectangle of concrete. Normally this is going to be about 8 inches thick, or yeah, I suppose 8 inches in thickness. But it's kind of going to depend on what is the size of your column. If we're using a W10x33 column out here, and then we have a C8 girt at about every 8 foot or so out here, then this distance from here to the outside of the column, or the outside of the wall panel, is kind of going to depend on that. This is probably going to be somewhere 6 to 8 inches. I'm not sure what it really needs to be based on what that girt is. You'll have to lay that out yourself if we're using a 2.5 inch thick wall panel. But I would say, in truth, 8 inches is probably the most common there. And then that sort of defines how far away the edge of this concrete is going to be from the center line of the column. Okay? And once again, I think I said last week, the column itself is probably going to be a W8 or maybe a W10. I think a W10x33 is a very common column section for an industrial building. Okay? And then if we're trying to call out the concrete here, once again, we go 3'6". Jeez, I'm trying to highlight here. We would go 3'6" minimum below the final grade. Why would we do that? Obviously, that is the frost depth, to make sure we don't have any soil heaving issues. And then because this has very limited structural requirements, we'd probably use 10M at 12 inches on center, I think would be the common reinforcing to use in there as well. But you can see, this is from a completely different detail set. But once again, we still have our rigid insulation along the exterior of the building, so we don't have any heat infiltration crossing that boundary. We have our little joint here. You don't need to call that out for this assignment, but it should be drawn. And sorry, I've drawn my pen here. So then the question would be, well, we're drawing it at the column. You know, that this isn't the column location. Obviously, there needs to be something going on beneath the column itself, and that's kind of going to look like what I've shown you here. So in the last week, I talked about, this little base plate detail, what's going on here, calling out the grout, calling out the base plate. Here you can see it's 2 inches of grout, 1.5 to 2 inches. Would be perfectly fine. But once again, we have this portion of the foundation that's going through, that is running continuously because the base of that prefabricated metal panel needs to be supported continuously, right? But what we're also doing is we're actually burying the base of the column below grade here as well. I've kind of seen it done both ways, but my understanding is that doing this helps to protect the base of the column. So I would say probably encase in concrete is what they'll probably do. They'll put the foundations in. They'll pour the foundation, excuse me, and then once again they leave these anchor rods in there. You come in, you put the column in, you then pour concrete to encase the column, and then you pour the slab around it. So this is not a wind column. I should have erased that. And then, like I was saying before, you put a little 3/4 inch chamfer on the near side, I would say on the exterior only, and that helps you provide that little drip edge that I was showing previously, so that the water moves away as best it can from the face of the foundation. Okay. Once again, obviously the slab is here. You can draw that in, but you don't have to label all components of the joint fill. That's not really necessary, but I think it should be drawn in. So the actual what we have now is a spread footing as opposed to a wall footing like we had before. So if you were to look top down on this, you would see the column, you would see the base plate with 1, 2, 3, 4. I will try to draw that a little more respectably. Bear with me. You will have the column. You will have the base plate. If we were looking top down here, you've got 4 anchors. This bit of concrete here, from here to here, that's called the pier. And then at the base here, you're going to have your spread footing. Okay, that's this portion right here. So, and it would kind of depend on the loading requirements, but unlike here where they would use a 10M, you probably go up to a 15M bar for a spread footing that is supporting the column. So I would say here, how many does it look like I had there? That's 5. 5, 15M each way. Okay. So I think that's what I was trying to cover at the base here. I think that's what I was trying to get at here. If I think of anything else, I will upload it. But up at the top, so like I was talking about, I want to bring up the parapet detail that we looked at last week, and hopefully I think I have that open here. So like I said before, obviously this parapet detail is going to be look a little different than what we're showing here. What we're likely to have is, once again, you're going to have a girt here, a C8 girt, that is going to push your prefabricated wall panel, that insulated metal wall panel outboard. They're working with a slightly different system here. It's going to come up under the parapet, and then I think looks somewhat similar to what we're showing here, except this is the exterior face of the parapet. Here they have some horizontal metal siding, just based on how this sort of bump out works for this particular example, which we may not have, but I would say that your prefabricated metal wall panel would come up and under, and then you would have something that looks similar to this parapet detail that you're seeing right here. There's going to be a prefabricated metal cap. There'll be a little bit of 1" by 2" wood blocking, so that you're sort of once again tipping the top of the parapet so that it drains towards the interior of the building, or the interior of the roof. Now we have this column here. I think I talked about it a little bit in the last lecture. We have this column here where you're going to need some sort of structure that cantilevers off, and they'll probably use, let's say, a WT8. I'd like to get something a little more accurate in there. So if we have our column, let's say our W10 by 33 column, our joist is landing on top of that column. We have our W12 by 26 coming in here. They're probably going to have to cantilever out some sort of, probably a WT8. And on that top of that WT8, you will have a cold formed metal stud, probably a 4" cold formed metal stud, and then a cold formed metal stud at the top, and then cold formed metal stud running in between. Okay, so that sort of forms the actual the actual structure of the parapet itself. Okay, so I think, to correct myself, I think it's probably more likely to be a 6" metal stud, and then at 16 inches on center. That's what's being shown here. That's the actual structure of the parapet itself. So just to repeat myself, there'd be a 6" metal stud up here, a 6" metal stud over here, and then a 6" metal stud running in between them. So this is the top, the bottom, and the actual structure of the parapet itself. So this one actually runs continuously, as does this one, to almost provide a guide to set in that metal stud to create the structure of your parapet. Okay. I feel like for shorter parapets, maybe a 4" metal stud might be used, but I suppose, like I say in the assignment, this is to be, I believe, 30 inches. I'll double check the assignment there, but I think if you're trying to get a little taller, perhaps that 6" metal stud might be more common. So then, this little WT8 here, refer to structural. This WT8 here, that not only will support the edge of the parapet detail like I'm showing here, but it will also provide the anchorage that the rods will use in order to drop, in order to support the girts themselves. So I would think you would probably have a girt up here, as high as you can get it, probably just below that WT, and then, like I was saying, at approximately 8 feet below, you would have your next C-girt, and you have tie rods, sag rods running in between them, so that you can hold up the girts themselves. Okay. So I think I'll stop it there. Most of what is being called out in this detail I would consider to be applicable here, other than what's going on the right-hand side, as far as the sloped metal flashing on top of the parapet. We have a little gypsum board between the metal stud, the 6" metal stud, and the EPDM single ply roofing. Then we have our metal deck below. I think I talked about that in the last week. This clip angle here, I think that uh, that's not really applicable in our situation, just based on that's almost acting something like a girt and for supporting the wall that was in this original detail, but I don't think that's directly applicable here. And then I think I talked last week about what's going on with the fireproofing there and how that's not really necessary here. One thing I will say is that the depth of this joist, it should be similar in terms of sizing the depth of that joist to a wide flange, in that if it's a 25-foot spacing on columns and this has a span of 25 feet, then this depth is probably also going to be around 12 inches as well. So I think that's all I have for now, and please let me know if you have any questions about assignment 2. So once again, your parapet details should look very similar to what I'm showing here, except obviously here we just have our metal wall panel coming up. So the width of this the width of the parapet here would not quite conform to what you're seeing here. This I don't think there's an actual dimension provided there, but your parapet would not need to be quite as wide, and that's part of the advantage of the system. Um, but I think that's about all I have for now. So I'm just asking for basically from bottom to top a wall elevation. My office hours are on Wednesdays. I can always uh, review your submission if you'd like me to take a look at it before it's due. That is perfectly fine. But otherwise, good luck with the assignment. I hope the semester's going okay, and I'll see you guys next week. Okay. Okay, great. Thank you.